Hi, I'm Adolph Oliver, and this is a video clip on general factoring strategy. Here's the idea. In recent video clips, we've covered lots of different ways of being able to factor quadratics. And the question now is, you have all these different techniques, and you got to factor something. What do you try first? What do you try second? And so forth. Well, here we're outlining the order that you'd go in to try all the methods out. So the first thing you always do is see if there's a GCF that you can factor out. Remember, we do have this standing rule that you have to factor completely. So if there's a greatest common factor, you've got to factor it out sooner or later. Do it right to begin with, because it'll often expose other things that you didn't see. Remember, when you pull out a GCF, you are using the reverse distributive law. Well, these are just examples. We're not going to factor these all away, but we want to know what they look like so you can identify it. Here we go. See these two terms? I can factor a common 3 out of both the 15 and 6, and I can also factor an x out of both of these. So there is a GCF, so we could do the reverse distributive law to begin with, and then we'd look at what's left to see if we'd go any further. Now, the next thing you look for is these shortcuts that we recently talked about. The difference of two squares and perfect square trinomials. Well, the difference of two squares, the name tells you what it looks like. You got two guys that are squares, which means they have nice square roots. The square root of x squared is x, square root of 36 is 6, and if you have the required minus in between, then you can get the factorization of this guy very quickly. Perfect square trinomials. You always want to look for these. Both these guys show up more often than you'd expect, and here's what you'd always take a quick look at when you have a trinomial. Do the first and last terms have nice square roots? Well, of course, the square root of x squared is x, square root of 9 is 3. And are they both positive? Okay, that's the first part of the test. You use the results from that to see if it passes the second part, and if it does, then you get the factorization very quickly. So you're always checking when you get a trinomial, 3 terms, first and last guys have nice square roots, and are they both positive? Then you apply the entire test to see if you have a perfect square trinomial. Now, on the other hand, if you don't have a nice shortcut, but you still have a trinomial, remember the general form for a trinomial is ax squared plus bx plus c. The a, b, and c are the coefficients. This is the x squared term, the x to the first power term, and a plain number. Well, what you home in on is what's in front of the squared term, the value of the a. If the a happens to be plus 1, then you can try reverse FOIL. Here's an example here. Remember, if you don't see anybody in front of the x squared, we assume plus and 1, and you try the reverse FOIL method on this. Well, what happens if you don't have a nice plus 1 in front? Okay, like this example here, we've got a 6 in front of the x squared, and there's no GCF we can pull out to get rid of that 6. So the a is not equal to plus 1. There's more interaction, and one of the methods that folks often use is known as the AC product method. It first starts out by taking the a value to 6 times the c value to 15 and going on from there. It borrows methods from reverse FOIL and from the factor by grouping, the next guy we're going to talk about. So what if you have, right to begin with, in your original problem, 4 terms? Well, here's what you do. You break them up in groups of 2 here, and then you turn around and see if there's a GCF you can pull out of these. If there is, and you end up with a common factor at the next level, then you can factor it all the way down. So factor by grouping has a life of its own here, and it also is what we use to finish up the AC product method. Now, the last thing down here, okay, check to see if you can factor more. Okay, so if you have x to the fourth minus 16, both of these guys have nice square roots. Square root of x to the fourth is x squared. Square root of 16 is 4. So this factors into x squared plus 4 and x squared minus 4. Well, this first guy can't be factored further. He's got a plus in between. But you see this guy here, he's a difference of 2 squares again. You can turn around and factor him once more. And so this is what we mean by always checking to see if you can factor more. Well, again, no new methods in everything here. What we're simply talking about is, okay, of all the things that you've learned, what do you try first, what do you try second, and so forth. So, quick little review of some of the other factoring things we've learned. Let's take a look here. And we've got two terms here, so this is not a trinomial. So none of our trinomial methods will work. But of course, the first thing we always try and do is see if we can factor out a GCF. Notice I can get a 5 out of both 5 and 45. So this is going to equal, okay, 5. Now I've got u to the 6th and u squared. So I can get 2 u's out of both of these. I use all of these up. Remember, the term that has the lowest power of the variable sets the limit. So 5u squared, okay, is the GCF. Now the leftovers, what do I have to multiply 5u squared by to make it look like 5u to the 6th? Well, u to the 4th. And then we have a plus sign. What do I have to multiply 5u squared by to make it look like 45u squared? Well, how about, I think it's just plain 9, isn't it? Well, let's check and see. 5u squared times u to the 4th equals u to the 6th. Okay, and then 5 times plus 9 is plus 45 and u squared. Okay, we're good. Now, if this would have been a minus here, we could have factored more because this would be the difference of 2 squares. But the plus doesn't work, so we're at the end of the road on this one. Okay, let's see what we got on this next guy here. We got a trinomial, but there's a GCF. There's a's all the way through. So let's factor out a single a, and that's because that's the limit here of the last term. And we get a to the 4th minus 4a squared minus 60. Okay, well, we factored the common a out. That's the GCF. What's left here? It's not a perfect square trinomial because first and last terms have to be positive. This is negative, and 60 doesn't have a nice square root anyway. So looks like this is as far as we can go with this one again, just pulling out a GCF, and sometimes that'll be it, but be sure that you do pull that GCF out. Now, this guy in the bottom, we got 4 terms here. Well, what ought to spring to mind is factor by grouping, and so let's group them, first 2 and last 2. Here we go. Now, we look for a GCF in each of these groups of 2. Well, in the first 2 terms here, there's a common 5, and I can also factor out an x. So 5x, the leftovers are going to be an x here, and a plus 3 here. Okay, let's double check this. 5x times x is 5x squared. 5x times plus 3 is plus 15x. Okay, now, the second group here. Let's see if we can factor out of this. There's a common 5 between the 5 and 15, and we can get a single y out. So there's going to be a 5y that we can factor out, but you can always factor either the plus of that 5y or the minus of it, and it's easy to see which way to go. Just compare the signs. If we can factor this all away, we'll have to get an x plus 3 out of this. And the x will come from the first term, the 3 will come from the second. So that's why you compare the signs first to first. Notice plus to minus is opposite. Compare second to second. Plus to minus is opposite. So if the signs are opposite, that means you factor out the minus version of your GCF. And remember, it was 5y. So we factor that out. Let's see what's going to be left in this first term in x. And I think it's plus 3 here. Let's double check to see. Negative 5y times x is going to be negative 5xy. Okay. Negative 5 times plus 3 is going to be negative 15 and y. Okay, well, this one we can factor. Notice we have a common factor now at the second level, x plus 3. So that's now our GCF. We factor that out and then put the leftovers in the second set of parens. And it's real easy to see the leftovers. 5x is what's left here and negative 5y there. So 5x minus 5y. Okay, now notice we would have to do one more thing here. This is factored, but you see there's a GCF here. In fact, we were a little negligent. We could have pulled that GCF right out to begin with, and that's what we should have done. But better late than never here. Factor out this common 5 on this. And so I'll put the 5 in front. We got the x plus 3. Factoring the 5 out of both of these, I end up with x minus y. Okay, well now it is factored completely. And of course, how you would check this to make sure it was correct, multiply these two binomials together using FOIL, and then distribute the 5 into that answer, and you get back where we were to start with here. Okay, a few more examples here. Remember again, we're not showing you any new techniques here. All we're doing is applying things we already know. Now, you can run into decimals as well as fractions in trinomials. And this is a case where we have decimals. Notice the first and last terms are both positive, and they both have nice square roots. Now you got to be a little careful with decimals. What's the square root of 0.01? It's 0.1. And the square root of s squared is s. Now 0.1 times 0.1 would give you 0.1, of course, or give you 1. But you need to have two decimal places, so that's why it's equal to 0.01. Likewise, over here, the square root of 0.16 is going to be 0.1 or 0.04. Now, by the way, you could put the 0 back in front of the decimal point if you want, or leave it off. That's kind of fielder's choice there. But the square root of t squared is t. Now, if we took 0.4, and let's correct this, this should be 0.4, not 0.04, because 4 times 4 is 16. We need to have two decimal places, so it'd be 0.16. Got to be careful with these things, like I said. Now, here we go. So both the first and last guys have nice square roots. They're both positive, and this could well be a perfect square trinomial. Multiply these two guys together here and compare it to the center term up above. 0.1 times 0.4. Well, that's going to give me an 8, but I need to have two decimal places, or going to give me a 4, I should say. 1 times 4 is 4. So I'd have 0.04, and then, of course, s times t. I think we're in business. Okay, the variable matches, but here's what we're really comparing. Is the coefficient double? Well, it certainly is. If you double 0.04, you'd get 0.08. So it is indeed double. That means this guy, who is a trinomial with decimals in it, is indeed a perfect square trinomial. Okay, 0.1s with this sign minus 0.4t quantity squared. Now, if you multiply this back out carefully, be careful with the decimal values, you'd get this original guy up here. Okay, let's take a look at the next one coming up here. Let's see. A perfect square trinomial, well, first and last terms are both positive. Last term does have a nice square root. It'd be 3b squared. but the first term doesn't. The 2 does not have a nice square root. So take a look and say, okay, about the only we do here now, this is a trinomial. The coefficient in front of the leading term here is not a nice +1. So we're going to have to try the AC product method. Okay, now remember, it just works with the coefficients. 2 times 9 is 18. Okay, 18 then is the number we're going to work with here. And since there's a plus here, we're going to be looking for 2 numbers. Okay, remember how you played a game here? 2 numbers that multiply together give me 18, whose sum has got to be 16. Well, I don't know if there's anything that's going to work. We can go 18 times 1. The sum is 19. That's not going to work. 9 times 2. The sum is 11. That's not going to work. Okay, and the only other thing we do is 6 times 3, I guess. Sum is 9. They're all getting smaller here. So it turns out that we cannot factor this one with the AC product method because we can't come up with 2 numbers that multiply together to give me 18. These all give me 18, but the plus here means I want the sum to be 16. No soap? So this one we cannot factor. Remember, there'll be many like this, but if you have a real problem, then you should get something that you can factor. Well, again, let's just look at one more example. As I've said, we're not showing anything new here. These are all techniques that you've recently learned. This one particularly here, here's what it is. X to the 4th, I'm going to change this, x to the 4th minus 81. Now, this is a difference of 2 squares. Square root of x to the 4th is x squared. Square root of 81 is 9, and we got the required minus here. So the first thing it does is this factors into the plus and minus of these 2 guys. X squared plus 9 times x squared minus 9. Well, here's what you have to watch out for. See the second guy? He's a difference of 2 squares again. We can again factor him. Not the first guy. The first guy's got a plus in between, and you can't factor him with real numbers. But this one you can. Square root of x squared is x. Square root of 9 is 3. So, since we have the required minus sign, this one here factors into x plus 3 times x minus 3. Now, don't forget the x squared plus 9 is part of the answer, so be sure you write it down here. Here it is. Okay, here's our complete factorization. How you would check this is first multiply the 2 simple guys together, get that answer, turn around now and multiply that times x squared plus 9, and you'll end up with the x to the 4th minus 81. Well, okay, what we've been doing here is just reminding you again of the order that you want to work these guys in. We haven't shown you any new methods. So the point again is what we started out with here. Let me flip it around. Here it is again. This is what you want to be very familiar with in your own. First, always try to pull out a GCF if it exists. Then check for the shortcuts. If they're there, boy, they're sweethearts. Difference of 2 squares, perfect square trinomial. Then, if it's not a shortcut and you have a trinomial, home in on the leading term. If it has a nice +1, try reverse FOIL. If it's not a nice +1, you got to try the AC product method. If you have 4 terms, okay, then down here, factor by grouping. Take them 2 and 2, pull a GCF out of each and see if you can factor the thing completely. And then, of course, always be looking to see if you can't factor more on this. So, there we are. We've learned all the factoring techniques. Now it's time to start making some use of these guys. So, Here we go.